Today, we're going to pull back the curtain on a hidden world of technology. It's all happening high above our heads, in unseen skies.
You know, most of us go about our days without ever thinking about it. But right now, there's this whole other layer of advanced machinery operating just beyond what we can see. It's like a constant ballet of high-speed physics and computation up there. And we're not talking about your average commercial jet. These are vehicles that are pushing the absolute limits of speed. I mean, they're challenging the very laws of aerodynamics as they travel faster than the sound they create. At the exact same time, a completely different kind of revolution is happening. Machines that can fly themselves for hours or even days on end. So today, we're going to dive into the science behind these engineering marvels. We're talking high-speed propulsion, high-stakes interception, and some seriously high-end autonomy. So let's start with the first, and honestly, the most powerful problem any aerial vehicle has to solve. How do you defy gravity itself? Well, the answer lies in mastering immense controlled power. At its core, it all comes down to a fundamental law of physics you probably remember from school. For every action, there's an equal and opposite reaction. Inside a rocket engine, you've got fuel burning, creating these expanding gases. As those gases get forced out of a nozzle at incredible speeds, that's the action. It creates the reaction we call thrust. And that's the force, the sheer power that's strong enough to push the vehicle skyward. And let me tell you, this journey is incredibly violent. From the second of ignition, that vehicle is under a tremendous amount of stress. It's accelerating with just brutal force, fighting against atmospheric friction the whole way. But as it climbs higher, the air starts to thin out. And this is a really crucial moment. With less air resistance to fight against, the vehicle can travel so much faster and way more efficiently, continuing its climb toward the very edge of space. Okay, so once a vehicle is launched and it's just screaming through the sky, how does it know where to go, right? Raw power is one thing, but it's not enough. It needs precision. It needs a brain. And this is that digital brain. Inertial navigation is just incredible technology. Imagine trying to navigate with your eyes closed just by feeling your own movement. That's basically what it's doing. By using gyroscopes to sense every tiny turn and accelerometers to measure every change in speed, the computer on board is constantly calculating its position in real time. And the amazing part? It does it all without needing any outside signals. It's a completely self-contained digital compass and map all in one. Now, let's talk about the scale of the speed here, because it's just immense. So Mach 1 is the speed of sound. Mach 5 is 5 times that. We're talking fast enough to cross the entire United States in under an hour. But here's the thing. When you start to travel that fast, the actual physics of flight begins to change completely. And no, this isn't science fiction. It's pure thermodynamics. The vehicle is moving so ridiculously fast that the air molecules in front of it just can't get out of the way. They literally stack up, compressing and heating up to thousands of degrees. It gets hot enough to turn the air itself into a superheated plasma that glows. So just engineering a vehicle that can survive that kind of environment is one of the greatest challenges in all of material science. So if you have these objects moving at hypersonic speeds, the next logical question has to be, how could you possibly stop one? This brings us to the science of interception, a field of physics that operates on just razor-thin margins. The process has to be absolutely perfect. It all starts with powerful radar systems sending out waves and then listening for the echo. As soon as an object is detected, computers instantly calculate its trajectory. But here's the really crucial part. The interceptor isn't launched at the object's current position. Nope. It's launched at a predicted point in space where both will arrive at the exact same moment. This really is the core question, isn't it? I mean, we're talking about two objects moving at thousands of miles per hour on a collision course. The timing has to be accurate down to a fraction of a second. How is that even possible? This analogy just perfectly illustrates the mind-boggling difficulty. It really captures the speed, the tiny target size, and the unbelievable precision required. It's a problem that pushes supercomputing, radar technology, and rocketry to their absolute limits. Okay, let's pivot. While some vehicles are absolute masters of speed, there's another technology that has completely transformed the skies with a totally different philosophy: endurance. And this is the world of autonomous drones. The contrast between the two is just stark. High-speed vehicles are sprinters, right? They're built for a single intense burst of energy. Drones, on the other hand, are the marathon runners. Their entire design philosophy shifts away from raw power to pure efficiency. Think long, glider-like wings from maximum lift and super lightweight materials. It's all engineered for one thing: staying in the air as long as physically possible, using advanced AI with no human pilot on board.
And this is the toolkit that makes all of that possible. Everything here is designed for endurance. The flight computer and the autopilot system, they act as the brain, making constant micro-adjustments. Satellite links provide location data, while all these advanced sensors allow the drone to see and gather information, all while it's operating on its own for hours or even days at a time. Now, this is so crucial. None of these technologies were created in a vacuum. They actually represent a convergence, a coming together of dozens of different scientific fields. I mean, just look at this list. To build these systems, you need experts in aerodynamics, propulsion, signal processing, and artificial intelligence. Every single machine up in the sky is the result of thousands of hours of research and testing across all of these disciplines. It's a massive team effort. And you know, that really brings us back to where we started. All of this incredible science, this amazing engineering at the very edge of what's possible, is happening right now, completely out of sight. It's this silent, constant presence, a hidden technological infrastructure that has fundamentally reshaped the world we live in, whether we see it or not. When you think about it, from mastering propulsion to creating an artificial intelligence that can actually pilot an aircraft, these systems are so much more than just machines. They're really monuments to human ingenuity. And I think that's the ultimate takeaway. Understanding the science of these unseen skies really gives you an appreciation for the challenges we've already solved. And it kind of makes you wonder, what impossible problems are we going to solve next?